Welcome to Sri Krishna educational channel. In this video I am going to explain about the chemical properties of amines, especially the basicity of amines of class 12th chemistry. The chemical reactions of amines is mainly due to the electronegative difference between the nitrogen and hydrogen atoms present in the case of the amines. In addition to it also responsible because of the unshared pair of electron present on the nitrogen, so that the amines are more active. And the amines which can be shows the different kind of reactions in the case of the primary, secondary as well as the tertiary amines, that is due to the different number of hydrogen atoms available on the particular primary, secondary, tertiary amines. These amines which also acts as a nucleophiles, that is because of the unshared electron pair which is present on the nitrogen, that is lone pair present on the nitrogen. So due to that which can be acts as a nucleophile. Okay, let me discuss about the basic character of amines. Okay, amines which can be acts as the bases according to Lewis, because the nitrogen has a pair of electron which can be donate the pair of electron and acts as Lewis base. Now the simple alkylamine, when it is treating with the hydrogen halide, so that case it forms the salt. Okay, alkyl ammonium salt can be obtained. Now the aniline which is treating with hydrochloric acid, it can be forms the anilinium chloride. Salt is obtained. Okay, here the anilinium salt or alkyl ammonium salt, which can be treating with the strong base like sodium hydroxide or potassium hydroxide. That case particular amine can be regenerated. Along with that we can get the water and halide ion. So here the alkyl ammonium halide which is treating with the sodium hydroxide, so that case we can get alkyl amine plus water and halide ion. So the anilinium salt or this amine salt which is soluble in the case of the water, but insoluble in the organic solvents like ether, alcohol, which is insoluble. Okay, this is the reaction is the basis for the separation of amines from the non-basic organic compounds which are insoluble in the case of water. And these reactions, in this case the amines with mineral acids, it forms the ammonium salts. This shows that these are the basic in nature. Amines have unshared pair of electron or nitrogen atom, due to which they can behave like Lewis base. The basic character which can be explained with respect to Kb and pKb values. Okay, it can be obtained when the amine, alkyl amine, which is treating with the water, so that case it forms the alkyl ammonium ion plus hydroxide ion. So this is a reversible reaction. Okay, when we write the equilibrium constant for this reaction, that case we can get the concentration of alkyl ammonium ion multiplied by the concentration of hydroxide ion upon the concentration of alkyl amine multiplied by the concentration of water. So when we are rearranging this, we can write this as K into concentration of water, which is equals to concentration of alkyl ammonium ion multiplied by the concentration of hydroxide ion upon concentration of alkyl amine. Okay, when we are taking this the product of equilibrium constant and the concentration of water, we can take as Kb, then we can write Kb equals to concentration of alkyl ammonium ion multiplied by the concentration of hydroxide ion upon concentration of alkyl amine. So when we apply the pH, okay, we know pH equals to minus log concentration of H plus ion. This is pH. So when we apply it for this, then we can write as pKb equals to minus log Kb. So when it has the larger value of Kb or smaller value of pKb, then that would be the stronger base. Okay, in the case of the simple amine, it's ammonia. Okay, it's a pKb value which is having 4.75 that is the pKb value of NH3 ammonia. Okay, whereas when comparing with this, we can write the different kind of amines pKb values. So methanamine has 3.38, N-methyl methanamine which is having 3.27, N-dimethyl methanamine it has 4.22, okay, ethanamine has 3.29, okay, N-ethyl ethanamine has 3. Next, N-dimethyl ethanamine has 3.25. Okay, next benzenamine has 9.38. Phenyl methyl amine has 4.70. Okay, N-methyl aniline has 9.30 and N-dimethyl aniline has 8.92. So these are the some of the values of the pKb. Okay, now based on this we can also get which are having the more basic nature. According to this, which are having the less pKb value that has more basic nature. So here the N-ethyl ethanamine it is having 3.00. So this is having the less pKb value, so it has more basic nature. So in case of the arylamines, okay, arylamines which is having the more, that is 9.38. So when comparing with the amine, if we ammonia which if we consider the alkyl substitute amines, those are having less value when comparing with the ammonia, that is NH3. Whereas arylamines, okay, which is more than the ammonia basicity, means we can easily compare here the alkylamines, okay, which are responsible for the positive inductive effect, which are responsible to the positive inductive effect. Okay, due to that the basicity of the alkylamines which is more in comparing with that of the ammonia. Here ammonia it has only 3 hydrogens, so the positive inductive effect is not possible, but the alkylamines the positive inductive effect is possible. But the arylamines, okay, which is again that can be varies, depends on the electron donating group as well as the electron withdrawing group which are substituted to the benzene ring. Next, the basicity of alkyl amines versus ammonia. Here the basicity of alkyl amine versus ammonia, when we compare with the alkyl amines and ammonia, okay, alkyl amines when those are treating with the H plus ion, so that case it forms the alkyl ammonium salt is obtained. Similarly, when the ammonia which is treating with H plus ion, it forms ammonium ion can be obtained. So these cases the alkyl group it can be, okay, having the donating nature, but the hydrogen which is doesn't have the donating nature to the nitrogen, so that here it is plus I effect is possible in the case of the alkyl amines, but the ammonia which it is not possible. So because of this reason the alkyl amines has more basic nature than the ammonia. In addition to this, here the alkylamines, okay, in the gaseous state, the basic nature that should become varies. That is, as the tertiary alkylamines has more basic nature than secondary alkylamines, than primary alkylamines, than the ammonia, because the tertiary alkylamines has the 3 alkyl groups, okay, donating towards the nitrogen. So as a result, the basicity, that means this unshaded pair of electron is highly available for the donation. Okay, in case of the secondary, there is a 2 donor groups, whereas the primary is only 1 donor group, okay, towards the nitrogen. So because of this, the tertiary amines which is more basic nature than secondary amines, than primary amines, than ammonia in the case of the gaseous phase. And other factor also which can be influence the basicity of the amines, that is the solvation effect. So here when the solvent like water, when the amines which are dissolved, so that case here the ammonium ions of the, that is primary, secondary and tertiary, so water which can be forms the 3 hydrogen bonds with the 3 of the water molecules in the case of the primary amines, whereas secondary amines only 2 of the hydrogen bond can be possible. A tertiary amine has only 1 hydrogen bonding is possible. So here the greater the stability of the substituted ammonium cation, then it would be the stronger base. The order of basicity of the aliphatic amines should be the primary, which is more than secondary than tertiary. Okay, this is opposite to that of the inductive effect. So that is due to the formation of hydrogen bond in the case of the aqueous medium. Here the inductive effect, solvation effect and steric hindrance of the alkyl groups, which can be decides the basic strength of alkyl amines in the case of the aqueous state. So here the alkyl amines, which are consisting, so which can be having the different kind of order in the case of the aqueous state. So here there are mainly inductive effect, solvation effect and the steric hindrance of the alkyl group, which can be decides the basic strength of these alkyl amines. So if we consider the ethyl amines, so ethyl amines, here the secondary ethyl amine, N and ethyl ethanamine has more basic nature, that is secondary, than tertiary, than the primary, than ammonia. In case of the methyl amines, so methyl amines secondary, which is more reactive than the primary, than tertiary, than the ammonia. So this is the ethyl amines reactivity and methyl amines reactivity. It's the basicity of arylamines versus ammonia. Here the pKb values of the aniline, which is quite high, which is 9.28, that is the pKb value of aniline. Whereas the ammonia, which is having 4.75, means the basicity of the ammonia, which is more than that of the aniline. Okay, because which has the less pKb value, that has more basic nature. Here the basicity of the aniline, which is less than the ammonia, that is due to the resonance. Okay, here the lone pair of electron present on the NH2 of in the aniline, okay, that is delocalizing towards the ring, benzene ring. So as a result, the pair of electron moving towards the ring, and it forms a double bond between the nitrogen and the first carbon of the aniline, and nitrogen gets the positive charge, and which can undergo the resonance. Then we can get the 5 of the resonating structures. So among these, the stability of the anilinium ion, which is more when comparing with the aniline, and here the ammonia has more basic nature than that of the aniline, because here the nitrogen and carbon, it has a double bond character, and the lone pair of electrons, which is moving towards the ring rather than available for the donation, so that the basicity of the aniline, which is less when comparing with that of the ammonia. Okay, next anilinium ion, if we consider anilinium ion, so anilinium ion, which can be forms only 2 resonating structure, whereas the aniline forms total 5 resonating structure. So which is having the more number of resonating structures, that has the more stability. So here among these, if we consider, the aniline has more stable rather than the anilinium ion. The stability of aniline is more than that of the anilinium ion. So the aniline and other aromatic amines, which has less basic than that of the ammonia. And any other electron donating groups or electron withdrawing groups are present in the case of the benzene. So that case, the basicity that should become varies. If the electron releasing group, like methoxy group, methyl group, present on the benzene ring, that case which increases the basic strength. Similarly, electron withdrawing groups like NO2, SO3 or COOH, halide, these ions are present. So that case, the basic strength that should become decreased in the case of the aniline. Okay, this is about the basicity of amines. Thank you.